All right, well, good morning.
Good morning.
My name is Matt Tomory. I'm the Vice President of Sales and Marketing at Innovatus Imaging. This is my 40th year in the imaging space. 25 years of that was service, and then I moved over onto the commercial side.
James Ashbaugh, Director of National Accounts with Innovatus. Been in radiology for more than 15 years now, covering most modalities, but specializing in MR.
So just a super quick overview of Innovatus. I'm gonna do an infomercial. Don't let Kennedy hear because we're not supposed to do this. Just a quick overview of Innovatus. We have 3 facilities in the United States. In Pittsburgh is our MRI coil repair center of excellence. In Tulsa, Oklahoma is our ultrasound probe repair center of excellence. And then in Denver, Colorado, we have our ultrasound design and manufacturing center of excellence, which is also FDA registered. So we are FDA registered for probe manufacturing. We also manufacture replacement arrays for our probe repair operation. So we're the only company in the United States that actually manufactures replacement arrays for ultrasound probes. So when the array goes bad, usually you just have to get another one because the array is the heart and soul of a probe. With us, in most cases, you don't have to do that. We can still repair your probe and save you from buying a replacement. And all those 3 facilities are available for virtual tours or in-person tours. We love when people come to visit us. I know travel's hard these days, travel budgets and everybody's stretched thin and so on and so forth. So we stream virtual tours. So if any of you would like to see any of these 3 centers or all 3 centers, just get a hold of me or James, and we'll arrange a virtual tour for you. And we stream it through Teams, and it's live and interactive. It's your tour. So you say, hey, I want to see this, this, or this. And that's what we show you. So let us know if you want a virtual tour as well. So without any further ado, we'll get started. So this is not something where you're going to have to take prolific notes and really think hard. We have tons of educational modules that we deliver, but for this, it's like let's just do something fun. Let's do something light, casual, and
bring the energy up.
Yeah, nothing that's going to break your brain on the last day of a big trade show. So this is going to be very chill and interactive. So, welcome, gentlemen.
How are you?
You missed a big intro.
I'm sorry.
That's all right. And you guys are with? Oh, welcome.
Yeah, we know all about this.
Oh, good. Yep, absolutely.
And that's a good thing, right? Okay. Here, let me give you the microphone a little louder.
That's a good thing.
So yes, some of you are customers, some of you are not, and maybe you'll be a customer someday. But without any further ado, did you pass out?
So we're just going to. I didn't.
Yeah, the way we're going to do this.
2?
Yeah.
Okay.
Start with 10. Right?
Start with 10.
Do we have enough?
Oh yeah, we have plenty. Yeah.
So what we're going to do is everybody's going to get
10
poker chips. And so in the style of Jeopardy, if we ask the questioner, we provide the answer, you provide the question. If you get it right, you get a chip. If you get it wrong, we take a chip from you. And the person with the most chips at the end gets the $100 Amazon gift card. So it's going to be, like I said, it's going to be very chill, very relaxed. Have some fun. Nothing too structured or formal.
Yeah, just take all.
Let me. Did we short you? Oh, one extra.
We got an honest guy here.
You know what? Keep that because you're honest. Sarah back there. Way to count, James.
I know. Hey, you don't pay me to count.
I don't know what I pay you for. James and I have worked together for quite a long time.
We're a load of honest people today. I really like this.
You want to take off your shoes and count these, or how are we going to do this? Okay.
It's a black and white.
Actually, we got to keep a level playing field then. I let Nasri keep his. So yeah, with the playing field is level. Okay, so let's get started. So again, the answer comes up. If you think you know the question that goes with the answer, raise your hand. First one to raise their hand gets the opportunity. You get it right, you get a chip. If you get it wrong, you lose a chip. So we're going to learn important aspects of imaging device troubleshooting, plus some quirky physics questions that we're going to throw in there. And the topics are relative to ultrasound, MRI, and quality and regulatory. And so, as I mentioned earlier, Innovatus, we do two things. We do ultrasound probe repair, and we do MRI coil repair. And then we also do manufacturing, but we don't manufacture for healthcare providers. We manufacture for different OEMs. So we're going to introduce the topic, display the question, and then use your knowledge, phone or other device to determine the answer. And if you think you know the answer, raise your hand. Okay, so thank you. All right, assuming the ideal care and handling and omitting options for probe repair, what is the expected lifespan of an ultrasound probe? Under? Pardon me?
3 to 5 years.
No.
Be specific.
We had another hand up back there.
8 years.
Closer.
Pass up the chip.
Yeah.
I'll be the chip collector.
Anybody else?
With that, 10 years.
Nope. How long? 12? Nope.
25.
No.
Jeez, we're just taking.
No. All right. It's 5 to 7 years. And that is assuming ideal care and handling. And when I say ideal care and handling, that rarely, if ever, takes place. Usually if something happens with a probe, it's somebody did something they shouldn't, or somebody didn't do something they should. And so probes don't often die of natural causes. So you can see here, these are some of the things that we've seen come in. So it's 5 to 7 years. This is an actual probe we received. So the handle plastic separated and the customer just kept using and using. And this is all scanning gel or acoustic coupling gel inside the probe head, which is really disgusting. And so we have care and handling programs that we deliver to healthcare providers. So if you guys are going through probes more than you think you should, and you're seeing a lot of what we term preventable damage, or that's our euphemism for neglect or abuse, let us know, and we can help you out with that. And the two items that can greatly shorten probe life is chemicals. So either people use an unapproved chemical. We saw this a lot during COVID. I had one customer who called me and said, I keep going through lenses on your probes. What are you guys using? It's not, whatever you're using, it's not working. I'm like, well, we use an approved material. It's the same as the OEMs. And I went and visited them, and they were soaking their probes in chlorine bleach because everybody was so paranoid about
over sterilizing.
Yeah. Well, it works as a good, it's a good disinfectant. It will kill all bugs, but it also kills probes because you can't use chlorine bleach on any probe. Or people use an approved chemical improperly. We have a program called Safety where we teach hospitals how to mitigate transesophageal damage. And I visited a site not long ago, and they were using an approved chemical. It's called glutaraldehyde. It's a very good disinfectant. It's nasty. And I said, so, what's going on? They said, well, we use this chemical, and then they got defensive. We use the right chemicals. That says, so we're here, we can use this. I'm like, how long are you soaking it for? In between patients. How long is that? Well, sometimes it's 10 minutes, sometimes it's a weekend. And so they were leaving the probe in this chemical for 48 hours sometimes, which was killing the probe. The instructions for use for that chemical was 12 minutes, and then you have to do a clean water rinse to get rid of all residue. And they were leaving it in for 48 hours. So they were using an approved chemical, but they weren't using it correctly. James?
What is the function or purpose of an MRI coil?
Ryan?
You started. Yep, that covers it.
Yeah. An MR coil is just nothing more than a really sophisticated antenna.
Yeah, just amplifies the signals and transmits them to the computer in the scanner, which processes the images. So spot on.
So yeah, let's go back and forth. You can do the MRI, I'll do the
Yep,
ultrasound.
for sure. So, and that's why there's so many coils in use on any given system. Just about any system should have roughly 15 different coils. Depends on how the MR system is being used, but you know, they're going to be for different parts of the anatomy. So kind of expanding upon that, they do come in various sizes. There's some newer technologies out there that work a little easier. The GE blanket coils, the air coils to the right. Prices are all over the place. I mean, there's, you know, a newer replacement coil can be, you know, $10, $20, $30,000, well into the $100,000 range.
Yeah, these new air coils are north of 100 grand. We've recently reverse engineered those so we can repair them for a fraction of that. Plus we give a longer warranty.
So Matt touched on us being an FDA registered manufacturer now for replacement arrays at our Denver facility. We also have a legacy as being an FDA registered manufacturer for MRI coils. We're the former MedRad company. We used to manufacture coils under the MedRad name, some private label. We've been doing this about 30 years and have, can't remember our current numbers on how many total coils we've repaired in that time frame, but it's a lot.
Oh yeah, it's about 600 different models. But yeah, our biggest clients for coil repair are the OEMs. And that's just a testament to, you know, we all know how OEMs feel about third parties. We're not thought about kindly. They'd like us all to go away. However, you know, all these multi-vendor OEMs and even their core products, we do multi-vendor repair for several OEMs. But there's one OEM that we repair their branded coil for them, and they're their service replacement. So when you get a service replacement from this one very major OEM, who, you know, we're not allowed to mention by name, we have NDAs, but you're getting a coil that's been restored by Innovatus.
And our goal with every repair is to return it to its original form, fit, and function. So inside and out, you can't tell the difference from new. Every single coil we repair, we have not just schematics, but we have specific work instructions per model so that our work can be replicated. We're using the same components. And with some of the OEMs we have direct access to their exact same suppliers. So we can ensure that we're putting the same parts back into the repair. Quality and regulatory. We can bounce back and forth on quality.
One of my favorite topics, especially in the environment that we're in today. So what is a written submission that demonstrates that a device to be marketed as safe and effective?
Clearance.
What kind of clearance? Mm-hmm. Do you know the name of the clearance?
501K.
You're really close. I'm going to give you a chip. It's 510. It's the 510K, but you're close enough.
No, he put it in the form of a question.
I didn't hear Ryan back there. Give Ryan a chip too.
Ryan gets a chip.
We'll split it.
You're welcome.
We're very relaxed here.
510K here.
So in Denver, where we are FDA registered, we do submit 510Ks for the probes that we manufacture. We manufacture for Hitachi Americas, and I can tell you who these people are because in that 510K application, we have to put who we're making it for. So this is public knowledge. And so NDAs do not apply here. So we make several probes for Hitachi Americas. We're all familiar with the Da Vinci robot. The ultrasound laparoscopic probe for the Da Vinci, we actually manufacture that for Intuitive Surgical.
We cannot help fix the Da Vinci robot.
Yeah, I wish we could. The first person that cracks that is going to be a billionaire. What is the name of the measurement device used to quantify the acoustic output of an ultrasound probe? So if you're measuring how much power or how much energy a probe is emitting, what is that device called? And you guys can use your phones if you want.
Somebody's pulling the phone out. No takers yet?
Go ahead and Google it. How do you measure, what device is used for measuring the acoustic output of an ultrasound probe? Pardon me? Nope. Not a watt meter. Yeah, no. No, this is, we're talking acoustic.
Son, you got anything?
Yes. Sarah got it. It's a hydrophone. There's another one that we use. It's called the radiation force balance. But the hydrophone is the answer. And so the reason we asked this question, this is actually a couple of photographs of a very sophisticated hydrophone that we have in our acoustic lab in Denver. So when we make a replacement array for an OEM probe, we do manufacture that under that FDA registration. And so we have to make sure that that array we're making performs as the OEM array, as the OEM intended. You'll never hear me or anybody who works with me say OEM spec. I cannot tell you that we repair or replace the OEM spec. The reason for that is the OEMs don't give us specs. And so how do we do it? The way we do it is we buy 3 brand new OEM probes. And those probes go to Denver and we benchmark them. We measure everything that's measurable on that probe. And we get all the characteristics, and we do 3 because 1 might be an outlier. So we want a decent sample size. And this is all per FDA guidelines. And then now that we've developed these specs, now these specs belong to us. We've developed our own specs for that OEM's probes, and then we manufacture those arrays to those specs. So that's how we do it. No, because it's not a finished medical device.
True or false? During repair, an MRI scanner is required to test the functionality of an MRI coil.
False.
Yeah.
Yeah.
So you were correct. It is false. An MRI scanner is not required in the repair of a coil to test it. So they are built to meet design specifications, but part of the design and process, even at the manufacturing level from the OEM, they are not using a scanner. They're using a test fixture. And that's what Innovatus uses. We have our own proprietary test fixtures that are used, they're model or OEM specific. So it allows us to build something unique and allows us to test all OEMs, all models.
Yeah. There's claims out there where people say they test every single coil they repair with a test bed. That's impossible. We do over 1,000 different coils. We probably have to have 100 different magnets, which, a magnet is what, $500,000, give or take, some up to into $1 million. And not to mention that, the power you would have to have in your facility to power 100 magnets, it's basically the grid of a small town. So it
would make the repair just financially unstable. I mean, you wouldn't be able to, it wouldn't make any sense to repair something.
So nobody can test a coil repair on every single coil. And so these emulators allow us to do that.
Yeah, so we can mimic everything that the coil or the magnet itself can do and return it back to, again, similar to our ultrasound business. We have our own internally processed specs. We return everything back to its original design. Quality and regulatory. In the clinical environment, no matter the modality, what should be used to assess image quality?
Yeah, Phantom.
Very good. That's what's going to provide a consistent result. It's not anything that you would want to, use a patient for. There's too many irregularities in a human subject, so a Phantom is able to provide consistent.
It depends on the construction of a Phantom. The MRI Phantoms are solid, so they can last, with proper care, they can last indefinitely. With ultrasound Phantoms, there's 2 different kinds. There's the solid block, which any of you watch Mythbusters? Ever watch that show? You know, that they always talk about ballistic gel. That's what the Phantom looks like, but it's not ballistic gel. It's a hard, solid surface or solid material that is designed to mimic the attenuation of ultrasound in human tissue. But then there's also liquid-filled Phantoms for ultrasound. There's a saline solution in there, and those do deteriorate over time, and you have to recharge them annually and calibrate them. So I don't recommend the liquid-filled Phantoms. They're a little tiny bit more accurate. They're nice Phantoms, but they just don't stand up to wear and tear. And I used to carry one, and I live in Arizona, and you leave it in the trunk of your car overnight, and you killed it. Whereas the solid Phantoms are stable.
Yeah, so we recommend, service engineers should not rely on the clinical image to assess the quality of that system.
Yeah, and this is why you see these two images. That's actually me. This is my common carotid artery here. You can see how clear that is. Years of clean living. You're right. But that's why. If you use different presets, your image quality is different. By using a Phantom, you're getting that consistency from test to test. 1540 meters per second. What is that?
Velocity of ultrasonic wave. Water?
In water? No.
Ryan?
It is a velocity. Velocity of what though? In yes, there we go. Excellent. Oh, I got one. So yeah, 1540 is the average velocity of ultrasound in the human body. And it is an average. It's, you know, if I look around this room, we all have different shapes. We're all different ages. I think I'm definitely the senior in this room by far. So that is an average. And the reason that's important is, you know, we talk about image quality and they talk about, you know, the OEMs talk about number of channels, number of elements in a probe. You can't beat physics. Physics is a law, and it's inviolate. And so when we talk about physics, we're sending beams of ultrasound into the body, constantly interrogating the body to create those cool images that we see. You can only do that so many times where you can display that image in real time. If you try and send too many lines, it takes too long. Even at 1540 meters per second sounds really fast, and it is, but we're doing it hundreds and thousands of times a second. And so you can only do that. You can only do so many lines. And you can skip over that.
Yeah. All right. It's one of the most frequently failed items of a coil. Very good. All right. So, like all cables used in the medical environment, they're constantly going through stress. Flexing, bending, around patients, around objects, being cleaned, dropped, everything else. So, in many cases, OEMs have the cables integrated into the coil, but there are some that are field replaceable units that you can take them out. But even with those situations, if you know it's the cable that's bad, you have to purchase one, they're very costly. And so they can range $5,000, $15,000 if you're purchasing direct from the OEM. At Innovatus, we have the ability to fully restore all cables for all manufacturers. And we don't just find the cut or the tear or the broken wire and splice something back in. We completely re-terminate it, restore it, just back the way it was intended. You know, a shortcut in a repair, if we just fixed a couple of the cables, a couple of the wires that we find, likely that there's problems behind that that's going to cause the cable to fail again in the next couple of months.
Yeah, actually, we got into this business. We have one OEM that we do work for, and they came to us and they asked us to fabricate cables for them. And we are now doing thousands of cables for this particular OEM per year. And so we've developed it as a product offering. We even do the new Philips D-Stream coils. They use fiber optics. And first time we saw that, we're like, oh crap, really? Why would you go and do something like that? And so, all right, engineers, come on, let's go. You got another project to do. And we have reverse engineered that cable now. And so now we can do the fiber optics as well.
We have a dedicated line in our shop for just cables. Part of it is just to restore those for that one OEM, but we do it as part of our normal repair process too. So we, train team members that are very skilled at these cables.
Uh-huh. Correct. Yeah. Initially, they were unrepairable, but we have a really large and dedicated engineering team, and so when we do see these new things come out, it's always the first time you open up something new and you see technology that you haven't seen before. You're like, oh, really? Why'd you guys go and do this? And then we put together an engineering team to tackle that problem, and we've done that with both probes and coils. We have engineering teams that are constantly analyzing new technology and making sure we stay ahead of the curve.
Yeah, when a new technology is introduced, we're not going to have a repair capability right away. Most of these things, they'll be in the field for obviously the first year under warranty, and then 2-3 years down the road gives us time to start seeing requests for them, demand for them, gives our engineering team time to get that moving and figure it out.
Which slide are we on? It's 11:27. I want to make sure
we can start moving a little quicker. I don't know.
Yeah. Between the two of us, we talk a lot.
Yeah, exactly.
Well, we're both in sales, so we're yappers. ISO certification, that's a big buzz, and that's pretty much where food and drug has landed as far as, does food and drug regulate our space or not? And I believe the standard that they're going to land on is you have to have a certain ISO certification for medical device repair. So what's the difference between 9001 and 1345?
I saw that actually, but I was going for it. ISO 9001 is a very general. Very, very general. And 1345, I think, is more specific to, and yeah.
Yeah, I'll give that to you. What it is, it's risk management. So when you are 1345, you have to do risk management. And so when we develop a new material, whether it's a lens, a plastic, a new array, or whatever, we go through risk assessment. What is the risk level of what we're doing? And the OEMs go through the same thing. So they have to do risk management as well.
I don't know if we want to spend time going over all of this, but
yeah, let's skip
these are
over.
scaled down differences between each of the.
Okay, so what details can be determined when you look at an ultrasound probe? It has letters and numbers on it. Okay, and so this particular probe, we manufacture the array for this. This is a Philips probe, but what do those letters and numbers mean? Oh, actually, Nasri had his hand up first.
Yeah, L means linear 12, and 12 to 3 is the frequency range, 3 to 12 megahertz.
Did you send this guy the presentation beforehand?
I'm sorry, it might have actually bad fingered that.
Sorry.
Sent it to the wrong person.
Yeah. So usually, and there's some exceptions, but the letters and the numbers denote the type of probe, the image format, and then the numbers typically denote the frequency range.
I know the C for curve, those are mostly for OB.
They can be, but then you see over here, you see there's a C here, C10-3, IC, EC. IC stands for intercavity, so that is an endovaginal probe. The C10 is also an endovaginal probe, as is the EC9-4. There's also intercavity probes. This is not exclusive to women. Us men can be on the receiving end as well. There's prostate probes for urology, where they're utilized to diagnose prostate cancer. Go ahead, skip that.
Okay.
I want to make sure I want to get out of here about 5 till.
Perfect. Although MRI technologists perform frequent QC checks on MRI coils, should MRI coils be included in a comprehensive PM program?
Yes.
You are correct. So they are very analog in their design, but because of that, they can definitely drift out of tune. And I think more cases than not, they are not part of a PM program. The performance will deteriorate over time, and many of these coils are in use for a long period of time. So, skip this.
Yeah, there's like, I think 80 slides.
Yeah,
So-
we got to get through it.
Yeah.
So please add it to your,
Yeah, and you guys will all have access to this presentation, by the way. So you don't have to take pictures or write it down. You know, this will be emailed to you.
anyone know the ISO quality standard for biocompatibility? It's an ISO standard.
Skip one.
I went too fast. ISO 10993 is the biocompatibility, and it's something that we do in our R&D lab in Denver to ensure that any of the materials we use in part of our repair process will not cause irritation or issues with the patient.
Yeah, because we are a registered manufacturer, we follow most manufacturing guidelines, even in our repairs. Now, I can start up probe repair, coil repair in my garage tomorrow, and I can do that legally. Any of us can. Now, are you getting those probes or those coils back to OEM form, fit, function, safety, and efficacy? Probably not. And so a lot of the things that we do, we don't do because we have to, we do because it's the right way to do things. So anything that we use in our repair process, whether it's a plastic and it's adhesive, a lens material, cable sheath, whatever, anything that touches a patient or touches the operator, we send a sample of that material out to a third-party lab. They implant that into a small animal and they watch that animal for 6 weeks and see if there's any irritation at all. Because we want to make sure that our materials are safe and effective for patients. So it is the right way. The OEMs do that as well. So we do act as an OEM. So there's several methods used by probe repair providers to replace the acoustic lens, which is the face of the probe. What could be the result of an incorrect lens dimension? Right? Yep. Yeah, and actually, I went through this. In fact, I quit my last job over this. My last company, I left in 2016. We were using Bayer Multi-Vendor Service, which is now Innovatus. We were using this company for probe repair. It was an ultrasound company, and my boss told me we're going to switch to another company. I didn't want to, and he said, you're going to. And so I got probes back from, we'll call them Acme Ultrasound, and I'm not going to name this company. They are here, but I don't talk about my competitors in a negative way. So I won't identify them, but we use this other company, Acme Ultrasound, and I got their probes back. I compared their probes, their repairs to the repairs that came from Bayer, because I have a clinical background. I've scanned myself, and the sensitivity on those probes was diminished. And so I went to my boss and I said, hey, these probes are not as diagnostic as they should be. And he's like, well, we're going to keep using them. He's a buddy of mine. We're getting a great price. I'm sure they'll get better. And so the next day I resigned. I said, not going to do that. I can't do that. And I called over to Bayer. I had contacts over there and I said, hey, I just quit my job. I want to represent your products. Find a job for me. And within 30 days, they created a position for me, and I've been here ever since. So bad probes can work. When I talk to clients, I say, look, my job is not to get probes working again. I don't care about that. I could give a rat's behind whether a probe works again or not. My job is to get it back to OEM form, fit, function, safety, and efficacy.
They went through a lot of effort to get it
right
designed and working the way that it is. It should be returned back to that.
Correct. But we don't have to. Third parties are not regulated. So there are people out there that are doing repairs that don't return probes back to OEM form, fit, function. What is a single component within an ultrasound probe that, if damaged, greatly affects the probe's repairability, right? Yep, the acoustic array. There's newer arrays coming out today, these matrix arrays that are not even a conventional array, they're a chip. So these are conventional arrays up in the, look at my shadow, I can use my finger as a pointer. So these
Conventional arrays.
Yeah, little rabbit.
Right.
So these are conventional arrays that we make in Denver, Colorado. And you see those little black lines, these stripes that you see here, those are called kerfs, and those are actually the cuts that we make in the array. We use a semiconductor dicing saw, and that cut is like 1/5 the width of a human hair. And those individual elements are about the width of a human hair. So those are the kind of scales that we're dealing with. Okay, skip that.
Flex coils should never be picked up or moved by the, nope. Anybody else?
Patient.
Well,
No, you shouldn't be picking up your patients anyways, unless you're really strong.
So, no, they should never be picked up by the foam section.
Yes.
Even though they're convenient and, you know, there seem to be nice handholds on them.
Yeah, it looks like a handle. It is not.
Yeah. So inside there are traces, and those are elements, and they are part of the function of the coil, and they can be fragile. So regular use picking them up will ultimately cause the coil to fail.
Although, who said the cable? Was it you, Ryan? I'm going to give you a chip back because that's actually true. Because some people do, not necessarily as much with flex coils, but with rigid coils.
It's all coils should not be picked up by the cable also.
Right.
So
Yeah.
it's a default answer also.
Yeah, that's worth a check.
So part of, we mentioned earlier that one of the biggest reasons for failure on a coil is the cable. And some of that's from poor handling, pulling it out of the system incorrectly, bending pins, plugging it back in incorrectly. So. Right.
Yeah, you start breaking latches and hinges and yeah.
So I won't spend too much time on this, but this is what it looks like on the inside of the foam. So, and you know, these traces can easily break. But we have the full ability to restore the foam, restore the trace, get it back looking just like nothing ever happened.
What is the typical length of the cable on an ultrasound probe? Ryan? Well, you jumped the gun, didn't you?
I'm gonna say
8 feet, yeah. That is a typical length. Now, endocavity probes, endovaginal and endorectal probes, they typically have somewhat of a longer cable, just because of the positioning on the patient. You need a little bit more slack. There's a common practice within the industry. Typically, probes will break, kind of like your iPhone cable. You know, if this is the scan head and this is the probe cable, you're constantly doing this. And so the cables start to break in here. So what some companies do is they do what's called a cutback. And so they cut this section out and then resplice it and shorten the cable. It'll work, going back to getting probes working again versus OEM form fit function. We do not alter the length of a probe cable by more than probably 3%, is about our limit. And so if we can't do that, we fabricate a new cable. There's also an industry practice. There's one size fits all cable harnesses out there that you can buy that other companies use. We don't believe in one size fits all. Medical devices are not one size fits all. An ultrasound probe is it's a class 2 medical device. You should not alter it. Now you can alter it, but you shouldn't. And so we actually fabricate, we're up to 145 different cables based on the OEM electrical performance, its resistance, capacitance, reactive capacitance, we call it. It's down to the length, the diameter, the color of the cable sheath, the materials, you know, all those things. So when a sonographer gets that probe back, it will look and operate and perform as a new one from the OEM.
And that sonographer may take note of a shorter cable.
Oh, they will. Sonographers are extraordinarily picky, except for their choices in men, because I'm married to one. So apparently she's not that picky about men.
What about the wireless probes that I keep hearing about?
It's a gimmick. There's a Siemens it's called the Siemens Freestyle. And yeah, it's kind of neat, but it's a real easy way to lose that probe, and you're subject to all kinds of interference. I'm not a fan.
So how many flexes do you believe that cable withstood before it started to deteriorate? And if you want to see an example of this, stop by the Innovatus booth. We have one of these devices.
Yeah, we call it a tick-tock. What it does is it oscillates the probe back and forth 180 degrees. And while it's doing it, it's twisting the scan head 180 degrees each way. So we're torturing the living heck out of that probe.
Granted, this isn't a video, but here's the cable. There's the probe up there.
10K? Okay. Nasri says 10,000. 1,000.
5,000.
This is a free for all, so closest one wins. What's
Okay.
Uh, The vendor says 25,000.
Okay.
So So we're not allowed to say that our materials are better than the OEM, because we can't alter a probe. And that is an FDA guideline. That is a regulation within the third-party space, is you cannot alter the design, or you will be having a conversation with Food and Drug and it will not be pleasant. And so I can't say we use something better. What I can say is when we come out with a new cable solution, I mentioned earlier, we fabricate about 145 different cables. What we do is it gets strapped into that torture device, and we put OEM probe in one cradle and we put a probe with our cable in the other cradle, and we torture them both at the same time. And we want to see which one fails first. And if ours fails before the OEM cable, we go back to the drawing board and re-engineer it. And this way we can quantify it. We call the device a tick-tock. What is the typical wire gauge in the wiring harness of an ultrasound probe?
Really small.
Yeah.
we're all on a free for all right now. So
Yeah. Take a guess.
100 millimeter.
No. Well,
Gauge.
Yeah, gauge.
wire gauge.
Yeah. So like the battery cable in your car is probably 6 gauge, I'm gonna guess. And then you get into your stereo speaker wires are probably 16 gauge.
Right.
So
They get gauges more obsolete. They get
correct.
As they get, yeah, the
Yep.
number goes up as the gauge or the diameter shrinks.
Yeah.
Okay, any other guesses?
5 would be like this. Now keep in mind within an
Five
ultrasound.
like your coffee cup.
Yeah. Keep in mind with this, if this was the ultrasound cable, we have a bunch of cables in our booth. Come visit us at 502. We can give you a tour. But within that main cable, there's up to 192 coaxials. So, and you got to fit that all into like a 3/8 of an inch, maybe 1/2 inch diameter cable harness.
Should I jump to the next screen? Yeah, and that's the trick. It's not the cable diameter or cable gauge, it's all the wires contained within. Right? And if there are 200 different wires within one cable. All right.
So that's what they look like. They're 42 to 44, but we actually have the new one. You can see Philips has a new probe. They're using 52 gauge wire. And that was one of those oh crap moments when we opened up the first one that we saw. We're like, oh my God, why did they go to this wire? And so this wire, these, now keep in mind, these are all coaxials. So you have a shield and a center conductor. There's 2 conductors within that coaxial cable. And we measure that, and basically these are the width of a human hair, and these have to be hand soldered. When you terminate a cable on a scan head or a connector, you have to hand solder that. Imagine the hand skills. I don't possess those kinds of hand skills. I couldn't even play Operation when I was a kid. So I totally screwed this up. These new cables, these 50 some gauge cable, the 52 gauges, these are fractions of a human hair. We actually are measuring these wires in microns now. And we have to hand solder these. And there's just a small space in between each wire. And we are now doing this by hand. And we have to, you can't mechanically strip these coaxials. We actually have to use a very specialized laser and do 2 passes. The first one gets rid of the outer casing, and the second one gets rid of the casing around the center conductor.
I put a factory once. The hand soldering, they were like little tiny, almost like they had little tiny. They said you couldn't have any one larger because the hand soldering was so intricately small.
Yeah.
Wow, you gotta have.
Well, it's under a microscope. They have to do this under a high-powered microscope while they're doing it. And we don't hire people with soldering skills. We hire manicurists, people who build models. We want somebody with delicate hand skills, and then we teach them how to solder. If somebody already knows how to solder, they've learned wrong. And then we got to unlearn that before we teach them the right way to do it for this type of work.
And they've been with us. We've got a great crew, and they've been with us generations.
Yeah.
We have multiple families, multiple generational families
Right.
working doing this.
Hey, we are at 11:46. So
Okay. Our third-party repair providers required to repair medical devices to meet OEM specifications.
Ryan raised his hand. Nope, they are not.
I'm being
I'm in charge of our sales team and our marketing team. And so I do competitive research all the time. And I go to some of my competitors' websites and you see, we meet OEM specs. We repair to OEM specs. I got one competitor who says, we exceed OEM specs. I'm like, really? Congratulations, good for you. Attaboy. No, you don't, because the OEM is not going to give you their specs. The only company in the world that ever got OEM specs from an OEM is us. During COVID, one particular OEM, a very recognizable name to all of you, approached us and said, hey, our plant overseas shut down because of COVID. Can you guys manufacture probes for us? And we're like, well, we need your specs. If we're going to do that, you got to send over your specs. They're like, I'm like, well, we're at an impasse then, because I can't just spin up tomorrow to engineer this. By the time we're done engineering this, COVID will be over. And so if you want it tomorrow, send the specs today. And my inbox, like ding, ding, ding. And I got the specs for all their probes, which, they've since asked me to destroy. But we're probably the only company that ever got OEM specs, but OEMs don't give them out.
How would they have expected you to do it without the specs? Just here's our stuff, reverse engineer it and pretend you don't see the.
Well, they thought the reverse engineering was quicker, but it takes us about 3 to 6 months to engineer a single make and model of probe, and about $250,000. Yeah, it's expensive to do it right. So you all get to play, and you just need to put out in front of you how many chips you're willing to bet on this question. And you can. Oh, we got
going all
a
in.
couple gamblers up here, all in. Okay, Dan is not that confident. He's only in for 2. Ryan, what are we betting here? Yeah, closest to it. No over or under.
Like in percentage of what?
No, numbers. So
Well, that's the tricky question. Innovatus since 2018, but we've been doing this for 30 years.
I'll go all in, I'll say 2 million.
okay. Now we are the largest probe repair and coil repair providers in the world. I'll give you that hint. And we run 2 shifts. So if that helps you at all. So so everybody's got their bet placed. All right, numbers. 3 million. Dan? 2 million. 4 million.
Okay.
1 million.
1 million. Nasri? $500,000.
Okay.
So 1 million, $500,000.
1,075,000.
1,075,000.
This price is right.
Fair enough. So 195,000 probes and 50,000 coins. No, actually,
No, yeah, he had $500,000.
yeah. So Nasri wins. You guys can keep the poker chips. They're just giveaways that we get here, but there's your gift card. You're most welcome. Thank you, everybody, for coming. We really appreciate it. It was fun. I like doing this. It's really relaxed and casual.
Yeah, I think we got it in on time too.
Brian, it was nice
Congrats.
meeting you.
Thanks for the participation. Means a lot. We tried to keep everyone alive a little bit. So thanks for coming. Nice. Thanks for coming. Good seeing you.